Yes.
Good. See, students, we have discussed equivalent and non-equivalent hybrid orbitals. Actually, orbitals means you can consider as lobes. Let me know answer from you. If I consider S.P. hybridization, then arrangement is how? Linear. Here is a one lobe, here is a second lobe. What do you think? These orbitals are equivalent or non-equivalent? How to know? See their orientation, see the angular separation, see the culture around that. In case bond forms, see the uniformity in the bond. For example, BCl2, one BCl bond, another BCl bond. Are they equivalent or are they different? One is experiencing other kind of interaction and other is experiencing different kind of interaction. Then those are non-equivalent. So my simple question is, in this linear arrangement, these two orbitals, are they equivalent or non-equivalent?
Equivalent.
Equivalent.
Yes, brilliant answer. Those are equivalent. If I consider a second hybridization, say sp2, the arrangement of those lobes, one lobe if I consider upside, one lobe making angle 120 degree, third lobe also will make angle 120 degree. Now tell me, these lobes are equivalent or non-equivalent? These orbitals are equivalent or non-equivalent?
Equivalent.
Yes, absolutely. It is also equivalent. Now let me take for the example, say sp3 hybridization. Four lobes are there. One lobe, if I consider its upside, other lobe will make angle 109 degree 28 minutes to that first lobe. Third lobe will make angle of 109 degree 28 minutes to both these lobes. And fourth lobe also will make angle 109 degree 28 minutes to each lobe previously represented. Again, I am asking the same question. It is equivalent or non-equivalent? Lobes or positions. See, here is the first position, second position, third position, fourth position. These positions are equivalent or non-equivalent?
Equivalent.
Equivalent.
Yes, brilliant. Equivalent. If I consider sp3d hybridization, then one of the possible structure or geometry is TBP, trigonal bipyramidal. Here I am representing one lobe. Here is a second lobe and it's a third lobe. It is in plane. It's like a fan. And other two lobes I'm representing by one different color. So are perpendicular to these previous lobes. It's a one lobe and below that there is what the other lobe. I want to know the answer from you. This hybridization or these lobes I can consider as equivalent or non-equivalent.
Non-equivalent.
Equivalent.
Yes. How equivalent? Non-equivalent because this orange color or red color orbitals are there, they are making 90 degree angle, and the blue color orbitals are there, they are making 120 degree angle to other blue colored lobe. Yes, whoever said equivalent, is the answer clear? Angle is different. See, here angle is 90 degree. So one kind of culture is there experienced by such red kind of the orbitals, and between the blue lobes the angle is 120 degrees. So different kind of culture is there, different kind of interaction is there. So those are not equivalent positions. We say, yes, help me, I want the help from you. Such kind of the position, this position you can consider, or you can consider this position, or you can consider this position. These positions are, what is the name of this position? By the way, for up and down, the two different positions are there. It is the one position, it is the other position. What are the names for green colored positions? This position is called, yes, in trigonal bipyramidal, two sides are there, two positions are there, two variations in positions are there. Which are those? See, what is the difference of these two positions? What is the label for that? I told last time. One is name starts with A. Other is the name starts with E.
Axial.
Yes. One is, yes,
Axial.
repeat. And other is?
Equatorial.
Brilliant. One is axial position or axial sides are there, and other equatorial. Now I need your help. Which sides or which positions are axial and which positions are equatorial? Green color positions here they were there. These are axial or equatorial? This one, this position, or which of these lobes are there? First lobe, second lobe, third lobe. As a fan blade I consider, or plane I consider, triangular plane I consider. Those are equatorial or axial?
Equatorial.
Equatorial.
Brilliant. Equatorial.
Equatorial.
Yes. Means these are what? Axial. Why? I'll give one answer. If you consider this as axis, then if I rotate this structure by simply 120 degree, you will get similar structure. 120 degree. So name of this axis is C3. On the other hand, if you rotate that structure passing through this axis, and if you rotate that, rotation of 180 degrees necessary, so that this lower lobe will come upside. This lobe number 3 will go to lobe number 2, and this lobe upper portion will come down on this portion. This exchange will be there, 180 degree. So name of this axis is a C2. There's a competition between C2 and C3. Who wins the competition? C3 wins the competition because its order, the 3 is a larger number than 2. Therefore, it is our principal axis. Principal axis, main axis, therefore those positions are called axial. And perpendicular to that is called equatorial positions. You are absolutely right. sp3d hybridization gives non-equivalent positions. Now I am discussing sp3d2 hybridization. Yes, what can be geometry for sp3d2? For example, sp means linear, sp2 means triangular planar, sp3 means tetrahedral, sp3d means trigonal planar is a one of the possibility. I am coming to second possibility. Now I came here to sp3d2. What's the geometry? What's the structure?
Octahedral.
Yes, octahedral. So I represent the octahedral arrangement. See here. A square, if I consider, means you will feel geometry point of view, it is not square as such, but angularly we are observing. Therefore, we can understand the angle is what? 90 degree. It's one position, second position. See here. Can join these corners. You can find such joining. It will come here up to. Here total how many sides are there? It is a first side, second side, third side, fourth, fifth, and bottom sixth. So there are 6 sides are there. If I have to represent the lobes, then I can represent the lobes here. Here's a one lobe, here's a second lobe, here's a third lobe, it's a fourth lobe, it's a fifth lobe, and here down will be what? Sixth lobe. So the 6 lobes are there. Angle you can see. I want to know the answer from you. Here orbitals are, or sides are, positions are equivalent or non-equivalent. Apply our concept.
Non-equivalent.
Non-equivalent. Yes. Any other answer? What's the answer I received? Non-equivalent. Answer for my question. Whoever answered. What is this bond angle? Upper orbital and the orbital representing site number 2 means this direction and upside direction. What is the bond angle?
90 degree.
Yes, it is 90 degree. 90 degree. What is the bond angle between position number 2 and position number 3? This angle. I am considering square. Position number 2, 3, 4, 5 are representing the vertices of square. Here you can consider so one diagonal, second diagonal. What's this angle? Angle between the diagonals. It is this angle. Angle between 2 and 3. Yes, are you understanding what I am asking? Here I am considering one square and the lines, how I am considering diagonal lines. So here is a 1, it's a diagonal line. Second diagonal line. Question is, what is the angle between those two diagonals? That's my question. Between position number 2 and position number 3, what is the angle? This position number 2 is the position number 3. You can consider the position number 2 and position number 3. What is this angle?
90 degree.
Yes, 90 degree. Between position number 3 and position number 4. Here, what's angle? This angle.
90 degree.
Yes, 90 degree. Between position number 4 and position number 5. What's angle? It's a position number 4. It's a position number 5. This angle.
90 degree.
Yes, it is also 90 degree. Between position number 5 and position number 2. Angle.
90
This
degree.
90 degree. Between position number 1 and position number 2, position number 1 and position number 3, position number 1 and position number 4, position number 1 and position number 5, everywhere angle is 90 degree. See, everywhere distribution, angular separation is uniform. If uniformity is there, then on what ground are you saying these orbitals are non-equivalent? Students, are you following what question I am asking?
Yes, sir.
Yes, sir.
Yes, then what will be the correct answer?
Equivalent.
Yes, it is a wrong answer, and correct answer is these orbitals are equivalent. Here logic you have to apply, and as you go on applying, conceptual clarity will be more. So here example of equivalent orbitals, equivalent position is there. If I have to discuss one more example, sp3d3. Yes. Somebody should help me. What may be the geometry? Yes, sp3d2 d3 means what's the geometry? As like somebody said, no, sp3d2 is octahedral. Likewise, yes, help me. Yes, waiting for reply.
Pentagonal bipyramidal.
Exactly. Pentagonal bipyramidal. And here, apart from this, I have to consider one line upside, means the central position if I consider, then upside, and other will be what? The downside. That also I can represent. Now I want answer from you. Here, total 7 positions are there. Which are those? I label them. It's a position number 1, upside. Position number 2, position number 3, position number 4, position number 5, position number 6, position number 7. Now you have to ask question to yourselves, are all these positions equivalent or non-equivalent? You have to think about the angular separation, angle between those, whether angular separation is same or not. With that you can work. You have to consider the angle. This, suppose if I join these all, position number 2, position number 5, position number 6 and position number 3, this central position, and this position number 4 if I consider, just I represent by different color this one. Yeah, so you have to think about the angle between 2, 3, 3, 4. Here it is not symmetrically represented, but it is a symmetric pentagon. All angles are same between 2, 3, 3, 4, 4, 5, 5, 6. By the way, you have to think about angle between position number 1 and position number 2, position number 7 and position number 5. See whether all angles are coming same or not. Yes, be fast. Actually, I had covered this point. This SP3 D3 not covered, but equivalent and non-equivalent positions I covered. What's the reply? Students, are you understanding question or not? That I am not getting.
Understood, sir.
Then what's the answer? Please reply. Let your answer be wrong. Don't worry about that.
Equivalent.
Yes. What is the answer?
Equivalent.
Equivalent. Let us verify that answer. Let us verify. We are considering pentagon. See, if when we consider triangle, what remains a bond angle? This angle in triangle, angle remains. Yes. Help me. Is it 120 degree or 60 degree?
120.
It's a 60 degree. It's a 60, it's a 60, it's a 60. Total angle, internal angles in a triangle remains 180 degree. Yes. Are you understanding what I'm saying?
Yes, sir.
Okay, this angle. But if I consider this one, such kind of arrangement, center of triangle and joining of vertices. Now help me. What is this angle? What is this angle? What is this angle? All angles are same. That angle is, yes, now you are right. What's the angle? It's a fan, no?
120.
Right. Now it is right, 120 degree. Previously I had asked different thing. So how to find angle, this 120 degree? Total, see how many ways this circle or 360 degree is divided. 360 degree divided by number of bonds 3, which is equal to 120 degree. If I consider square, center of the square and line joining of all vertices, then what is this angle? What is this angle? What is this angle? What is this angle? Apply such formula. 360 degree divided by 360 degree divided by
4.
4. So what should be the answer? This angle
90.
is 90 degree.
90.
Likewise, student, I am considering now pentagon. Means I consider one baser line. Here it is making one angle. Here it is making one other angle. This one. All angles, these angles are there, no? These are uniform. I am not interested in those angles. I am interested in the angle made at center by each vertices. So if I consider the vertex number 1, that's upper, not upper, this for this diagram you can consider this one or pentagon and this vertex. What is this angle? Or what is this angle? Or what is this angle? Or what is this angle or this angle? Apply the formula. 360 degree divided by, what should I do now?
5.
5.
5.
Yes.
72.
72. Right. 72 degree is a bond angle. So what you are finding here, separation is only 72 degree, 72 degree, 72 degree, 72 degree. But if you consider position number 1 and position number 2, what's the separation? This one, position number 1 and position number 2. What's the angle? Position number 1 is upside, as like trigonal bipyramidal was there. In the same way, in octahedral also, one point was up and remaining was the square plane. In trigonal bipyramidal, triangle was a plane. In octahedral, square was a plane. In pentagonal bipyramidal, pentagon is a plane. Yes, I am asking the question, what is this bond angle between position number 1 and 6? Bond angle between position number 1 and 5. Bond angle between position number 1 and 3. All are same. All are same. What's the angle? Consider one pentagon and upside is one bond. So what is the angle made by that upper bond to that plane of pentagon? No, at least this was simple I did. I am not understanding what's the exact problem. If not clear, you can say not clear. Otherwise, answer. Actually, the main thing which I want to discuss, yet I now started that. Yes, what's the question? Somebody has asked question, I think, or answer it is. I could not hear that clearly.
Sir, repeat once.
Okay. Prathamesh, I am asking position number 1 and position number 2. What is angle? Or position number 1 and position number 3, what's angle? Or position number 1 and position number 5, what's angle? Position number 1 and position number 6, what is that angle? What is that bond angle? It's a pentagon and up one bond is there. So my simple question, that upper bond is there and this pentagon, what is the angle between the plane of pentagon and that upper bond? Is that question clear, Prathamesh?
Yes, sir.
What's the answer? Yes, for other students, if you don't know, then say don't know. I'll repeat the concept or I'll repeat the question again. Yes, can anyone answer? It is not a planar structure, it is a non-planar structure.
Don't know.
Don't know. Okay.
Don't know.
See, when you consider the fan, say the ceiling fan, consider it's the one blade of the fan, it's the second blade of the fan and third blade of the fan. Answer for my question. The blades of the fan, exception don't think about, blades of the fan, they are in plane or not plane? Actually, angle remains because the wind comes. But in general way, simple way, I'm asking, this arrangement is a planar or non-planar?
Planar.
Yes, it is planar. It is in one plane. Now this fan is hanged. We are hanging that fan to the roof. So I hope you will consider here we are hanging that fan. So this position makes some angle to the plane of the fan. I'm asking, what is that angle? Holder, fan is hanged up to the roof, no? So that shaft is there, that rod is there. And the blade of the fan, what is the angle?
90 degree.
Right, 90
90
degree. In trigonal bipyramidal, similar situation was there. If you consider square pyramidal, then in spite of 3, there will be the 4 blades to the fan. See, fan also remains of 4 blade. Then answer for my question, what is the angle made by this upper rod to the blade of the fan? If blades are 4,
90 degree.
90 degree. That's the question. Now consider one fantastic fan, interesting fan, where 5 blades are there. One more extra blade that I considered. Then what will the angle between the upper rod, which is hanged to the roof, and these blades? What will that angle? That I am asking. This was one question. That angle is
90 degree.
90 degree. Yes. See, one where angular separation is 90 degree and other where angular separation is 72 degree, it means angular separation is not equal. If it is there, then that answer, whatever you have given, is it correct? Will the positions be equivalent or non-equivalent? Positions will be non-equivalent. Non-equivalent. Similarly, last time when I discussed 5 coordinated, that's one interesting hybridization, and that was sp2d2. In that, how was the arrangement? Arrangement was square pyramidal. I need to consider one square and I need to consider only one bond from upside down. So now positions will be, it's the position number 1, position number 2, position number 3, position number 4, position number 5. Now answer for my question. These positions are equivalent or non-equivalent?
Equivalent.
I want other answers.
Equivalent.
Equivalent. Good. Any other?
Equivalent.
Equivalent.
Equivalent. Further 2 answers I want.
Equivalent.
Last.
Equivalent.
Okay, fine. Because what logic you applied, you are right. Whatever I said, you have followed that. But one error is there. Now I will inform that. What you thought, the bond angle between position number 1 and position number 2 is 90 degree. Position number 1 and position number 5 is 90 degree. Position number 1 and position number 4 is 90 degree. Position number 1 and position number 3 is 90 degree. By the way, angle between 2, 3, 2, 5, 5, 4, 4, 3, everywhere angular separation is 90 degree. You are right. But only angle is not our criteria. For that, I had taken this example. It was applicable for others also, but I not confuse you there. You have to consider along with that culture, along with that surrounding. Means this position number 1 is experiencing how many 90 degree repulsions. 90 degree repulsions. Because when we consider the orbital, means we are considering the lobe from in upside direction. We can consider lobe in this plane. We can consider lobe in this plane. Here likewise, here we can consider lobe in the plane, lobe in the plane. When we consider such lobes, then The upper lobe, I show it by different color. See here, this lobe, red color lobe, makes angle 90 degree. But how much 90 degree repulsions are there? How many 90 degree separate bonds are there? Answer for my question. With position number 1 to this position number 1, how many 90 degree separations are there? How many nearby bonds are there who are separated by 90 degree? I want that number. It is called as the 90 degree repulsion experienced by that red color orbital. I want answer. I want number. How many 90 degree repulsions are there? How many 90 degree bond angles are there? That's my question. To that red orbital. Are you imagining? It is like 4-blade fan and one shaft is there, one rod is there, which is hanging from the roof. My question is that rod makes how many 90 degree angles? Those many bond pair repulsion will be there.
4.
Right. How many 90 repulsions are there? 4. Keep this number in mind. Okay. Now ask the question. Take any position. Say position number 3. This position number 3 or this bond or one of the blade of the fan makes how many 90 degree repulsion? How many 90 degree angles? Let it be with the other bond. Let it be with the hanging rod. How many 90 degree repulsions are there to such kind of sites? Like position number 3. It is applicable for position number 4 also, position number 5 also, position number 2 also. But at this moment, think about one of the blade, that is blade number 3. One of the position, that's a position number 3. How many 90 degree separations are there? Means I say 90 degree repulsion. How many are there?
Question not clear, sir.
See here, it's a square. I am considering one more position, that is upside down. Means it's a fan. I am hanging that fan here. I am considering that's a hanging rod likewise. The blades of the fan also I represent here. Yes. Could you able to imagine these 4 blades?
Yes, sir.
To those blades
Yes,
I am
sir.
saying it's a position number 2, position number 3, position number 4, position number 5, and it's a hanging blade. It's not a blade, it's a hanging rod. My question is, if I consider this blade number 3, this position number 3 makes 90 degree angles with others. How many 90 degree angles? That's my question. Is question clear now? This
Yes,
blade,
sir.
this position number 3 makes 90 degree angles. How many 90 degree angles it makes?
2.
Yes. What one is thinking? It with position number 2, it makes 90 degree angle. With position number 4, it makes 90 degree angle. One more 90 degree angle is there. Help me.
Downside.
Downside position is not there. Downside orbital is not there. Downside arrangement is not there. Downside bond is not there. This position number 3 makes one more 90 degree separation, 90 degree angle. With whom? That's my question. Here you have explained how many 90 degree repulsions are there. In the way, same way you have to think. It is a hanging rod. Hanging rod makes how much angle to blade? It is a hanging rod and here the 4 blades are there. This hanging rod makes angle to each blade. How much angle that hanging rod makes? How much angle that this red color lobe makes? How much angle that axial lobe makes? That already you have answered. Somewhere problems are there. Yes, 90 degree. So this is also one more 90 degree separation. The student who has answered, no, 2 90 degree separations are there. That is wrong. 3 are there. One with position number 2, one with position number 4, and one with position number 1. So how many 90 degree repulsions are there for such position number 3? 3 90 degree repulsions are there. Keep this number in mind. Students, are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Yes. So one where 4 90 degree repulsions are there and other where 3 90 degree repulsions are there. If I consider axial position number 1, 4 90 degree repulsions are there. If I consider position number 3 or position number 4 or position number 5 or position number 2, 3 90 degree repulsions are there. Repulsion, interaction I'm talking about. Because of that, the positions become non-equivalent. Means from saying point of view, this position number 2, which has 390 degree repulsion. Position number 3, 390 degree repulsion. Position number 4, 390 degree repulsion. Position number 5, 390 degree repulsion are equivalent. These positions are equivalent, but overall structure what? If I consider position number 1, this position or this position number 1 is different than the position number 2, 3, 4, 5. Position number 1 is represented by green color, and other positions, position number 2, position number 3, position number 4, position number 5 are represented by yellow color. Different color indicates different alignment, different interaction, different kind of position. Bond angle is one of the criteria about which you are right, but additional criteria informed to you. You have to think about 90-degree repulsions. 90-degree repulsions are different. Now answer for my question. Such kind of the structure, that's a square pyramidal, will be with equivalent sides or non-equivalent sides?
Non-equivalent.
Yes, now you come to the proper answer, non-equivalent. So let you consider this trigonal bipyramidal arrangement or such a square pyramidal arrangement. Overall 5 bonds are there, means when 5 bonds remain, 2 kinds of arrangements are possible. 2 types of hybridization are possible. One is SP3D, geometry is trigonal bipyramidal, and other is SP2D2, geometry is square pyramidal. So now I hope and expect that equivalent positions and non-equivalent positions or equivalent orbitals and non-equivalent orbitals or equivalent sides and non-equivalent side. Is this concept clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Let me revise. SP, equivalent or non-equivalent?
Equivalent.
Equivalent.
Yes, yes. SP3, equivalent or non-equivalent?
Equivalent.
Yes. SP2, equivalent or non-equivalent?
Equivalent.
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 SP3D2, equivalent or non-equivalent?
Equivalent.
Yes, equivalent. And other orbitals which we discuss, those are non-equivalent. Yes, give me example of non-equivalent hybridization.
SP3D.
Yes, SP3D. Second example.
SP2T2.
Right. What is the geometry for SP3D? SP3D means TBP, trigonal bipyramidal. SP2D2 means square pyramidal. Sometimes square planar also is square pyramidal, SP. Yes. Third example.
SP3D3.
Yes, SP3D3. It is pentagonal bipyramidal structure. Yes, students, actually I was interested to complete this topic in first few minutes, this equivalent and non-equivalent, because already we had a discussion of all orbitals. I remember I discussed the SP, I discussed the SP2, I discussed the SP3, SP3D2 was a homework for you. SP3D was discussed. SP2D2 was discussed. SP3D3 was a homework for you. I understand that now assignments, other subjects assignments also are there. Maybe tutorials are there, but there is no excuse. You have to work for this. My main point that about this equivalent. Once equivalent and non-equivalent positions are clear, then which atom will go to the which position, about which I wanted to give the explanation. About the percentage of S character and percentage of P character, we had a already discussion. Calculation also we did. Additional homework also is given to you. Yes, do you remember that?
Yes, sir.
Yes.
Yes, sir.
Yes. Now, shortly, because the next point, too many points were there. Out of that, at least one point I covered there. Example is trigonal bipyramidal structure. I represent the structure trigonal bipyramidal. I consider one triangle here. I consider one point is coming from the upside. It is better I rotate this triangle. Okay, you can consider this completely down. Right? Yes, help me. What may be the type of hybridization? For such trigonal bipyramidal arrangement, type of hybridization will be, yes, last 2 minutes, be fast.
SP3D.
Yes, it's only possibility. SP3D. But positions are not equivalent. So we say non-equivalent. Position number 1 and position number 5 are of one category. Position number 2, 3 and 4 are of other category. Will you give me any example for this sp3d hybridization? Phosphorus? Yes. Phosphorus?
PCl5.
PCl5.
Yes, PCl5. So, first instance, you may feel that all 5 chlorines will experience the same culture. Absolutely not. This upside chlorine and downside chlorine experience one kind of culture. Equatorial chlorines experience other kind of culture. Because of that, whatever this black bond is there, this bond length, means here at the center here is phosphorus. So phosphorus and upper chlorine, phosphorus and lower chlorine. So I said that axial phosphorus chlorine bond length. And if I have to say the other, phosphorus and equatorial chlorine, phosphorus and equatorial chlorine, phosphorus and equatorial chlorine. So it's an equatorial phosphorus chlorine bond length is not equal. I want that you should guess which bond length will be more, this axial or equatorial, will be more. Where is the more repulsion, more 90-degree separation, more 90-degree repulsion, bond length will be more. Hint I had given to you. Which bond length will be the more? That's the question. Axial or equatorial? Who will be the more? These black color bonds are with more length or purple color bonds are with more length? Which bond length will be the more? Yes, axial bond length will be the more, because this axial bond is experiencing 190-degree, 290-degree, 390-degree repulsion. This axial position experience 390-degree repulsions, while this purple color position number 2, position number 3 experience 190 repulsion upside and 190 repulsion downside. So how many repulsions are there? 290-degree repulsions are there. So here 90-degree repulsions are absolutely more here in axial position and more 90 repulsion. So those atoms will remain away from the center, and because of that, this bond length will be the more. Axial bond length will be the more. So it is absolutely correct. Okay. Firstly, I tell to you, suppose if the molecule would have been the PCl3F2, F is more electronegative. The Bend's rule says, listen carefully, I am discussing in detail later on. Bend's rule says more electronegative atom, that is which one? Fluorine, will occupy the axial position. These two fluorines, one will be the upside and other will come downside, and chlorines will remain the equatorial. Why? It is a Bend's rule. Reason I'll explain to you. More electronegative species will prefer that position which has more P character. So what it is, about which we will have the further detailed discussion, or which has less S character, some more proper wording. I repeat, the point about which I wanted to discuss actually today this lecture, but I am going to discuss it later on. That hint I am giving to you, sp3d is a hybridization that is undergone by PCl5 molecule, but all chlorines are not equivalent. 1 chlorine, 2 chlorine, 3rd chlorine and other chlorines are with what? The different kinds of the culture. So bond length is different. In PCl5 also bond length remains different. Axial bond length is more than that of the equatorial. It's a conclusion. Is a first example. Second example about which I discussed is a phosphorus trichloride and difluoride. Two different atoms are there. One fluorine, other chlorine. Bend's rule says fluorine will occupy that position where less S character is there. Less S character is there. Or axial positions time you can consider. Detailed explanation we will see next time. So students, can you prepare the notes of today's lecture?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Where you seeing the presentation?
Yes, sir.
Screen was notable, no? Yeah. Okay.
Yes, sir.
Okay, students. So shall we stop now?
Yes, sir.
Yes. I declare here today's session is over, but I want to know from you, when shall we conduct the next lecture? Sunday evening will do, or today evening will do, or next week we will adjust. If you are busy in this week, next week we will adjust, because we have to adjust at one lecture, extra lecture. Extra lecture means not extra, regular lecture only. Please reply next week.
Next week.
Next
sir.
week means, yeah, or Sunday or today. When? Give that date or day. Okay, Shilpa has given answer next week. Please reply next week. Yes, further 2 replies I want. Next week. Okay, next week we will adjust that additional lecture. Meanwhile, complete your assignments if are there. Okay, students, I declare here today's session is over. I am going to stop the recording.